North American continent and couldn't figure out why. The only reason I bring that up is to say, even though this kind of science seems really old because we're talking about things that are millions and billions of years, it's actually a fairly recent science. So most of this has been discovered within the last 50 years, which is kind of amazing. But this is calcite geode that my neighbor mined out at Keokuk, Iowa, and this was formed by crystals of salt at the bottom of the ocean. And again, this is from Iowa. So these rocks have been broken apart, and you can just see the crystalline structure there, which is kind of cool. I have a whole bunch there. And then I also have these ammonite shells. This is from Kremlin, Colorado, which is nearby where I grew up. And these are seashells at the top of the foothill mountain. So it's kind of it's just an amazing thing. We thought we'd just show that and talk about that because it's an interesting anecdote. But it also is where I want to start here. We're going to transition a little bit from talking about the geosphere in terms of the deep earth and plate tectonics and start talking about this link between the geosphere and the biosphere, and that critical link is soil. And in case you were wondering, hey, I don't know, it seems like we're moving fast on this topic. I'm not sure if Hava and Z actually care about that. Well, here's my 221-page dissertation on soil fertility. So it's kind of a topic that I'm passionate about, but unfortunately we won't be able to spend as much time as we'd like to. But we're going to do some soil science with our columns that you guys prepared yesterday, and then we're going to talk about some of this critical link between the geosphere and the biosphere today. Feel good? Excellent. All right. So here are the major things, and I just wanted to call this out before we get started, because in the text, you're not going to read anything about the mining or human impact. We had a little bit of disagreement on how the text is organized, so we're just reading a couple pages on that soil unit, and we're just focusing on these learning outcomes that are associated with this part. Right now in our narrative, we're in sentence number 1, which is the earth is highly interconnected with a lot of systems that vary over space and time. The soil system is one of those. So we're just going to be talking about the formation of soil and understanding about this idea of weathering and erosion. So, in review, let's just look at the rock cycle a little bit. From yesterday, one of the things that we quickly figured out when we were doing the shadings of crayons, the different colors of crayons could be represented of different minerals that are found. Minerals are different compounds made, of course, of elements, but rocks are composed of minerals. And what's so key to keep in your mind straight here is we don't classify rocks by what they're made out of. They're named by that, but they're not classified by that. They're classified by how they're formed, but they contain minerals, and understanding that rocks are made of minerals is going to come up here again in a second. So I wanted to make sure we were all settled on that point. But a rock, as just thinking about, well, what is a good working definition that we can use for a rock? Well, it's an aggregate of one or more minerals that are pushed together. What kinds of things can form a rock? Do you remember what agents of change that we saw yesterday? Yeah. Heat is one. Pressure is the other. Which one of those is greater? Heat or pressure? Which one can make rocks more significant? It's the heat, for sure. And so we'll keep that in our mind as well. And so this process, understanding this process, is really key. This can't be the first time you've encountered it in your life, but that's why we're not spending much time on it. But I don't want people to get confused. Just because we're not spending much time doesn't mean it's not very important. So understanding the nuance, the sedimentary rock is formed of sediments, and it's made by pressure. And we can take that rock and turn it into igneous rock. If we expose it to magma and intense heat, it can become an igneous rock. Or if we expose it to a little heat and pressure, it can become metamorphic. And a metamorphic can become an igneous if it's exposed to a lot of magma and heat. Or it can become a sedimentary rock if it's ground down in sediment, and then gravity and pressure and stacking of different material on top. Well, then we can create sedimentary rock. So it's not a unidirectional thing. We can go back and forth between these forms, and the way that the rock is formed is how we know what the classification is. People feel good about this? Just a quick point of review. All right. So this table, I pulled some of the elements out of the textbook and I organized it together just so that you could see it but this is essentially what you saw on the other side, but I wanted to pull out here because we looked at it specifically yesterday, basalt and granite. Well, the differences between these two is intrusive versus extrusive, and it has to do with how quickly that magma cools down. But the process that it came from magma makes it an igneous rock. Sedimentary rock is compressed over a long time. It's usually fairly uniform, so if you see a rock and you're looking at it and the material is all uniformly put together, then usually if you have a good trained eye, you can see that that's a sedimentary rock. Metamorphic, here are some examples. You saw them in class in real time last time, but now that you understand rocks a little more, hopefully you can make sense. Marble is a common, a conglomerate of things. It's a metamorphic rock. It looks like half-melted crayon that has been pushed together. Agreed? Great. Not everything on here is explicit to write down. I just wanted to show that here. This is, wait, where's my other thing? Uh-oh. I lost my slide. Dang it. That's all right. Well, I had a slide, and I'll make sure I get it included on the one that gets pushed out there. When I learned about the rock cycle, I learned about this little song that goes to the tune of Row, Row, Row Your Boat. I was just going to put it up there, but it's one of the best mnemonic devices that goes with this to help you keep it clear in your mind. So I just wanted to provide that as a resource in case you're like a song-oriented learner. I don't know if that's a thing or not, but anyways. Everybody feel good about the rock cycle. The rocks, interestingly, are foundational to understanding soil. So, the next thing we want to talk about is the formation of soil. In review, what are rocks made out of? Minerals, right? What do you think soil is made out of? Probably minerals as well. So what makes soil different than rock? If I'm holding a rock, like if I grab, these are not perfect examples, but these are rocks, it'll work. If I grab a rock like this, versus if I had a handful of soil, what is the difference? Yeah.
There's organic stuff in soil.
There could be some organic stuff. Beautiful. Keep that in your mind. We'll come back to that. What else? How does it actually look? The density is a little bit different. How do you mean? I like that. It's help. A rock is solid and it's very compact. In contrast, the soil looks like what? It's loose, meaning it's made up of tiny, ground-up, small particles. This is the key that I want you to understand. I like this just because it shows that rocks move around and they move all over the place, and that's kind of cool. But the key is, soil is made out of ground-up rock. So what kinds of things can grind up rock? Well, here's a word that we're going to use, and we're going to talk about it very specifically whenever we're discussing soil right here. So we're talking about the formation of soil, but instead of saying rock, the rock component in soil is actually the parent material. So if you hear this, the material part makes sense. The parent means, well, this is where all the soil was derived from this material. So it's that perfect lineage to that word. But the parent material, it's the rock that makes up the soil, the parts of the soil. So this is the inorganic compounds, the elements that make up the minerals that were once one part of a rock. And the way that this process goes, I was kind of planning on, I ran out of time in preparation to get here to make this happen, but I was going to bring a giant hammer and a glass of acid, and it would be a nice demonstration to kind of talk about this next key term here, which is erosion. Surely this is not the first time you've encountered the word erosion in your life, but what we're talking about is grinding that rock down into these small particles so that they become more loose and more compact, and that could be through a number of different processes that we'll discuss here in a second. But this is literally the physical removal, and here's a misspelling right here. This should be rock fragment, so we're breaking it down in the ecosystem through different processes. Feel good about erosion? Great. Whoa, here we go. So factors that determine soil properties. There are going to be 5 of these that I want you to keep track of, and each one has a role in making a soil into what it is, and based on each one, they don't always it's not always the same process across all types of soil. There's some variation, so it depends on how much exposure to each one of these elements helps to determine what the soil actually looks like. The first one I want to talk about, and the text is a little bit small here, so I'll try to read it to help you guys out, but that's topography. We've already gone out to our micro locations and looked at how the elevation changes across a small amount of space. It also changes across a large amount of space. Sometimes that large amount of space is created by glacier movement or giant rivers, but the topography really matters. So the soils are subjected to erosion, and so the link here is physical processes are acting on the rock and grinding it down, and it's acting according to gravity, where things are moving from a high area to a low area. Which way does it go? High to low, for sure. Same here. It goes from high elevation to low elevation, and as erosion takes place, we're grinding rock into smaller pieces. So the topography of a given area matters for how the soil is going to look. Another is the climate. This, I feel like there's parts of this that are really intuitive, and then there's a part that is a little bit less intuitive. So it says the first one is the soils don't develop during freezing. When you have frozen water, it's locking all the material in place, so these soil formation processes that you would expect to happen under normal conditions are no longer happening. And so anything that's permanently frozen or frozen temporarily, like during winter here, we don't have soil being formed during those times. Interestingly, and why this might matter is, in highly productive ecosystems like the rainforest near the equator, the soil never is frozen, so we're having soil processes and the formation of soil happening constantly over and over. That cycle is in overdrive. The second one here is there's an indirect relationship with organisms, which I'm going to pull organisms up here next. So biological organisms also contribute to the formation of soil in a few key ways. Keep this in your mind about the indirect relationship. I'll touch that on the very end here. But plant material, so everything that you see that a plant is made out of, it's made of matter because of the law of conservation of mass and the fact that the earth is a closed system in terms of matter. We know that matter had to come from somewhere. Two of the places it could come from are either the earth, i.e. the soil, or the air. And so plants are taking nutrients, and they're also leaching things out of from their root systems back into the soil. So there's kind of a cycle there. And decomposing material, which could be plants, small animals, microorganisms, etc. As those die, they're broken down by natural processes, and their matter becomes part of the soil. So organisms are very involved here. So here's my question. I said climate has an indirect relationship with organisms. So why does climate matter for this piece here? Why do you think? Yeah?
Climate determines what organisms live where.
Climate determines what organisms live where. Keep that in your mind. That's perfectly stated. That's going to be where we're going to go next in this class. So how much energy is available, how much heat energy, how stable is the environment, all of that's going to contribute to what we actually find there, and those organisms are going to contribute to soil processes. So in the Antarctic or the Arctic circles, we have soil formation being much slower because of both freezing and the lack of relationships. The next one is time. And time is a little bit fuzzy because it's not just time, it's the things that are associated with what happens over the course of time. So I put a few things in here. The inputs of organic matter can develop into deep, fertile soil. So that refers to the natural breakdown of the compounds that make up soil. Those processes take time for molecules to break down. They can follow certain rules that are associated with the bonding and covalent and ionic bonds. And so time matters there. But time also matters in terms of exposure. So if I say we have rain falling on an area or intense heat and sunlight falling on a certain area over time, if I measure what that effect is over 1,000 years, it's much greater than if I measure what that effect is over one day. So time matters as this link to exposure. And then the last one, this cycles us back to where we began, something that we've already discussed, the parent material. So that's made of the rock. What are rocks made out of again? They're made of minerals. So the actual compounds that are present also contributes to the formation and the character and the physical properties of soil. Does everyone feel good on this slide? Fabulous. Here's what we're going to do next. I'm going to do a 4-minute, and I'd like everybody to attempt these 3 questions based on what you just learned. And the questions are, describe the development of soils from parent rock. How does that take place? Try to conjecture how it takes place. I don't know why this looks like that, but it says, explain how nutrient values of soil change with age. So thinking about what I just spoke about related to time. And then the last one, describe how soil development can occur simultaneously. And by that I mean, how is it being created and how is it being broken down? Ready? We're going to go for 4 minutes. Let me get this timer going. I'd like everybody to try to attempt these questions, by the way. Beautiful. Computer's not working very well today. Whoa, too loud. There we go. Everybody should write something. This is a good thinking exercise based on what you've just learned. Go for 1 more minute here. Take about 30 more seconds just to finish up some quick thoughts. All right. Ooh, man, I don't know what happened to my slides. I don't think that I'm using the right version right here. Sorry about that. But let's go over these answers really quick, and I'm going to go back. I had another picture that I want to show, but I'm going to go back to this picture right here because this is kind of the key. You have rock. At the beginning of our planet, when the Earth was formed, everything was made out of rock, and slowly over time and through cycles, we've been breaking that down. And so this is what the process looks like. You have erosion that comes from physical processes. It can also come from chemical processes, and it's slowly breaking down that rock. And that's how we're coming up with soil. Let me go fast forward to the questions again here. So the first one, the idea is erosion. The second is the nutrients are changing because they're constantly being moved back and forth due to this key thing right here, which is organisms and cycling. And then the last one is, well, organisms can be taking from the soil And then if more organisms are dying, like what happens with seasonal variation, if we have a bunch of leaves fall off the trees and that material decomposes, we have soil being formed through those processes. If we have intense weather happening at the same time, we could have a breakdown of soil. If there's wind blowing away the topsoil as an example. So there are many right answers for 3, but we could have the buildup and the breakdown of soil happening simultaneously, and I wanted to make sure that we saw that. This part is really critical to understand and to get filed in your mind. You should have these horizons memorized. The word horizon, you can think of a synonym for that would be layers. So when we took our soil pillar, maybe you saw at where you were sampling at your microclimate location that there were actually different layers. We call those the horizons. And if we think about the formation of rock due to erosion, it kind of makes sense. Which area is going to have the most exposure to erosion? The top or down low? The top. The top for sure. And where are organisms going to be interacting with the soil? Down deep or near the surface? Near the surface as well. So this area where we have the accumulation of a lot of organic material, the O stands for organic, it's the O horizon, and it's made of decomposing material and living material like this critical link between the geosphere or the lithosphere and the biosphere being all of the living beings. Right below that is this A horizon. It gets kind of weird because they're not in perfect alphabetical order, but A, B, and C are in alphabetical order. There's a relationship between those. O stands for organic, so that's a way to keep it clear in your mind. But the A horizon is for the topsoil. So this is an area that's rich with nutrients. It's expensive to buy if you go to Home Depot, and the reason why is because it has a lot of minerals and it has some organic material that's right below the O horizon where the living things are. So this is one of the most nutrient-rich and key parts of the soil. That's the A horizon. It's the topsoil. I'm going to skip the E horizon for a moment and come back to that. But the B horizon is the subsoil. And so this is an area where as the soil is being broken down and elements are moving through, water is carrying material from the top levels to the lower levels. We have an accumulation of those. It could be metals. It could be an accumulation of nutrients. That is accumulated in this area called the subsoil. So we go from topsoil to subsoil. And in between that, you don't always have this E layer, but the layer of the soil that facilitates that movement according to gravity and the movement of water is called the E horizon, and we also call that the zone of leaching because that's where I really like the way that I wrote it here. It's a place where the movement of soil material is going between the A horizon and the B horizon. We could actually kick up material from the B horizon, but we'd have to do a physical disturbance. But just according to gravity and natural processes, we're going to have some exchange of material, and it's going to go this direction, according to gravity, down. And so the zone of leaching is where that movement is taking place. And the accumulation of all of that material is in the subsoil area. And then last is the C horizon. This is the least weathered. It's the closest. And then we would actually have the parent material or undisturbed bedrock down here below that. This is the first time maybe you encountered it. It's kind of a quick look at it. You should absolutely spend time in your private study memorizing what these layers are and the properties of each given layer. So, just thinking about this for a second, how do the factors of soil formation produce the soil horizon? The factors are time, climate, organisms, topography. Which one am I missing? Maybe I said them all. Parent material. How do those contribute to the formation? Does it make sense in your mind, the link? So if we're breaking down the material, if we're moving the material, if organisms are acting on it, that's how we come up with this column of soil right here. The soil profile is what we call this. Everybody feel comfortable with this? Great. Oh, now here's my dumb picture. This was supposed to be on the other slide. This just shows time, and then rock being broken down through processes of erosion, and then the particles, the largest particles, the least disturbed are on the bottom. That's the sea horizon, and then the bedrock, and then the ones that are being turned over and eroded the most, where there's a high interaction of wind, weather, rain, organisms. Those are the smallest particles, and those are due to the chemical, physical weathering processes that occur there. Great. All right, so I want to show a quick video here, and then I want you to think about these questions while you look at this video, and then I'm going to give you a picture here. This is one of the videos. You maybe have seen the one on our homepage for the syllabus. It's only 1 minute, but this is going back to our first things that we discussed in this class. What are the ecosystem services that soil provides to the environment and to humans? And then thinking about how you can produce a model here in a second. Let me play this video.
I am the soil. I am in the hills and in the valleys, the farms, the orchards. Without me, humans could not exist. But you treat me like dirt. Do you realize that I am just a thin skin on this planet? And that I'm actually alive, full of organisms that grow your food. But I am broken, aching, overused, sick, because of you. You have withered me away to less than half of what I used to be just over 100 years ago. Are you paying attention? I am turning to dust. So maybe you could treat me with a little more respect. I suppose you still want to eat, right?
We're going to look a lot in this class at the human connection between the way humans are impacting the environment and different elements of the environment. This gives you a little foreshadowing of what those exercises are going to look like. But in order to do that well, let's first understand these things. So every person independently should again try to answer these questions. What are the ecosystems services provided by soil? We've seen some of them in this slide already. You should be able to intuit some others, thinking about how they matter to the environment and how they may matter to us as a society. And then the second thing I want you to do also during this time, and you can use what you have on the notes, but what does the soil horizons look like? Producing an independent model and label that model with the horizon layers and some of the appropriate labels as well. We'll do this for a couple minutes here, and then I have one last thing to end our time. Trying to mix it up a little bit with the music. I thought we'd go for the rural roots today. Does anyone need a refresher on the definition of ecosystem service? An ecosystem service is something that the resource is doing that benefits the ecosystem, or in this case, there's something that the environment or the ecosystem is doing that could benefit human societies. So in which ways, which things the soils do? We'll talk about them together at the end. For number one, it looks like a list most likely. Everyone should be able to do number two. Number two is ambitious to do in 4 minutes, so I should see everyone working pretty well during this time. in this case probably looks like a picture. Labels. Go for about 30 more seconds here. Beautiful. Give me some of the ecosystem services that we can think of. Yeah. Nutrients. Beautiful. Very good. To grow food. We've got to anchor the plants somewhere, which is part of it as well. Yeah.
Indirectly, oxygen production.
Oxygen production indirectly. We're going to talk about that a lot coming up here soon via photosynthesis. Yeah.
The recycling of nutrients allows new plants to be grown each year.
Recycling of nutrients, so we know because Earth is closed in terms of matter that we're not going to be able to get new matter. So it is important that we move that matter through the ecosystem in some way. Nutrient cycling is good. I got two here. Reusing organic material, I love that language. Water filtration is going to be key as well. We're going to talk about that next. All right. The next one is the soil diagram, which hopefully you were able to just kind of do. I just wanted to get quick practice to keep it close to your mind. Oh, sure. Now you can't even see this. My goodness, it's just one of those days. The picture here is an image from the textbook. Again, I'll remedy this by the time I send you out the slides. But it shows some of the ecosystem services that are associated with moving things back and forth. And hopefully you feel good about the soil horizons. Does everybody feel like they understand what's going on here so far for soil? To give you an idea of what we're going to do tomorrow in class for this group, we're going to do a soil laboratory based on the columns that you guys made and particle size, physical properties, some of the chemical properties associated with soil. So come ready to get your hands potentially with a little bit of soil and dirt on them. That's going to be part of our lab tomorrow. For tests, I have a lot of people, I know in my class at least, that are interested about the tests. If you want to come talk to me, I have some availability today after school. We have a reassessment opportunity happening tomorrow morning at 7:30 if you're interested in that. You don't have to email me or Mr. Hoppa, just come during that time. Likewise on Friday during the Day 6 Collaborative, if you want to come to reassess then, that's great. Just come, you don't have to email us. If you have questions about which ones you missed, or things that you might have struggled on, and those times don't work for you, then let's work out something so that we can get your mind right. But keep this in your mind, heat energy is the big idea. So if you're not sure what's going on, heat energy is the engine of climate and weather. That's what we spend all of our time on. So if you don't know what the answer is, heat energy is probably related to it, or is it exactly? All right, sound good? All right, you guys are golden. Thanks for today. Have a good rest of the day. We'll see you soon. Yeah. Yes.
You have it like this for the different horizons? Are those four just the main ones you need to know about?